Hi everyone. We're actually going to start today with a very important topic, homeostasis, because everything in our human body, anything in the environment, there has to be some kind of balance to maintain life. That could include temperature, regarding, let's say, you or I. Temperature, heart rate. There's a lot of different things that has to be regulated. So let's see some of these things that we can do. All right, so we've all had those days that we're running here and there. It's really hot outside, or you could be working out. Have you ever gotten so hot that you started sweating? Well, that is actually a part of homeostasis, because as your body temperature goes up, you don't want your cells frying. Your body would actually go through these mechanisms to ensure that your core temperature goes back down. That's an example of every day of how homeostasis actually works. Now, I know for sure I love cakes. I love chocolate cake. I love chocolates. I love candy. So my question is, have you ever had a yummy piece of sweet cake or anything sweet, but you live to see another day? I know this sounds like a ridiculous question, but that one piece of cake, it could be rice, it could be any starch. If you ingest it, your body will digest it, and you can end up with having carbohydrates like glucose into your bloodstream. Now, if the glucose continues to rise with no end in sight, that in turn would not be good. So through homeostatic mechanisms in the body, you wouldn't actually have that problem. And so that is another process that I'm just showing you of homeostasis, like how it can apply to everyday life. Having these checks and balances in our body will actually ensure that we live a life, right? So homeostasis, the actual definition for homeostasis is the state of biological balance. That means if something gets shifted inside of our body, it will then go back to a normal set point. Everything in our body has a normal set point. Blood pressure, body temperature, blood sugar, whatever may be, there is an actual set point. So if you start deviating away from that, your body's going to try to bring it back to its normal set point. An example of when homeostasis does not work properly is the actual disease diabetes. You've heard of diabetes. Diabetes can be caused by several different reasons. You can have individuals not produce enough insulin, or there's something wrong with the insulin receptors. There could be various reasons why diabetes can occur, but it is actually one of the top several diseases that we see in our country. So sometimes homeostasis is disrupted or harder to achieve, and we can see that here. Another example of homeostasis not working correctly due to various factors is hypertension, this high blood pressure. That's another issue that we see in our country that is linked to cardiovascular disease. Also, diabetes is linked to cardiovascular disease. The reason why I'm showing you these examples is to show you that disruption of homeostasis can actually be bad for you. Now, thanks to modern medicine, we have medications that kind of help us out when those mechanisms go bad, but it's still important for you to know we need these biological balances in our body. Now, biological balance, or homeostasis, does not just randomly occur. There are actually feedback loops that feed into homeostasis. So there's the positive and the negative. Now the negative is that true feedback that we see when we have a set point and bring things back. But I will talk about those two feedback loops so you can understand. So if we look at negative feedback, this is an area that a lot of students mix up. They hear positive and negative feedback, and immediately they think that negative is bad. In the case of maintaining biological balance, bringing something to a set point, negative feedback is actually good. Okay, so remember, negative feedback is good. So if you take a look at this balance scale here, if you have, let's say this is what it should be like. This is what the set point should be. If it actually goes in one direction or the other, what negative feedback does, it brings it back to normalization. Right, so if you get hot, your body temperature needs to come back down, so negative feedback will kick in. Negative feedback is the most common feedback loop we see in our system, and remember, this brings you back to a set point. Now, positive feedback, people actually think positive feedback is the preferred feedback of the body. Typically, it isn't. However, there's certain things that positive feedback is good for, but for others, not necessarily. So here I'm showing you a picture of a guy slipping, right? So this doesn't look like it's a good situation for this man at all. So he sees this body of water, or he probably doesn't see it, and he slips and he starts falling. So the event that is occurring for this guy right here is that he is falling and everything is going to be a disaster. The box will probably hit him on the head and so forth. All right, so I put this there as something for you to realize that when we talk about positive feedback mechanisms, they do not bring back to homeostasis. They don't bring it back to how it normally was or to a normal set point. What happens is that it leads to an event. So whatever is happening, there's going to be a magnification of the response. So if you look here at the guy, normal homeostatic mechanisms, if the guy started slipping, he would stand right back up immediately. But when we talk about positive feedback, the event of this guy is that he's going to continue to slip, continue to fall till he lands on the floor. Okay, that's the event. So there is a magnification of a response, and it leads to an event. And one thing you also have to remember that a lot of students mix up is that it moves away from the set point. So if there's something in the middle, this positive feedback mechanism will not bring it back to the middle. It will take it to wherever it's planning on going. And in certain diseases, we do have positive feedback actually playing into that. But I'm going to talk about some of the positive feedback mechanisms that is actually good that we see in the human body. So the first one that a lot of textbooks talk about is in terms of positive feedback is labor. The event is labor. You know, during pregnancy, the baby is growing inside the mother. That is wonderful. But we want the baby to eventually come out. When the baby is ready to come out, we don't want it to continue to grow to adulthood, obviously, in the mother. So there will be a reaction that occurs in the body where the woman starts getting contractions due to hormones like oxytocin that's being produced. Now, oxytocin doesn't just stay at one level. You know, like contractions don't stay at one level. Contraction keeps coming. It gets magnified until the event occurs, which is the baby coming out. So one example of positive feedback is labor. You're going to have a magnification of result of hormones that will cause to an increase in contractions that will eventually lead to the event. That's the term, event, which is childbirth. Another example of positive feedback that we see in our body or in our systems, especially in women, is the event of ovulation. All right, ovulation is the release of an egg from the ovary, and obviously that will be for reproduction. So we see here that there will be a series of hormones that will start shifting, such as the luteinizing hormones. The hormones keep going higher and higher and higher. So as you can see, higher and higher and higher until the event occurs. Now, what is the event? Ovulation. Something is happening. All right, another event of that occurs in the body in positive feedback is blood clotting. All right, so the event is to clot the blood. So you'll get more platelets coming, more platelets, and more platelets. All right, so these are showing you some examples of positive feedback in the body. Notice they do not bring back to a set point. They all lead to an event. All right, so what is actually going on in homeostasis regarding the negative feedback loop? All right, so let's talk about the negative feedback loop, and then we'll give some examples of negative feedback. So there is some kind of stimulus that will be triggered. So the stimulus can be temperature, it could be pH of the blood. I mean, it could be anything, any stimulus. So if a stimulus is reached, like let's say you pass the threshold of the temperature, there's going to be some sensor that picks that information up. So once the sensor picks up that information, it's going to take it to a processing center or control center that will see what the change is and then send out a response to actually make a change to bring something back to its set point. We call that the effector. So let's take a look at an example that includes these. Now, we're going to actually look at this example of body temperature. So remember I said the stimulus. All right, so if we're looking at this, let's say the body temperature exceeds 37 degrees Celsius. That's equivalent to 98.6 degrees. If it starts going up, that's not the normal body set point. Now, of course, everybody's temperature can vary as a normal set point for them, but I'm using this as an example. So what is the sensor that's picking up the temperature change? Well, there are nerve cells in the skin and brain, all right? So the nerve cells pick up that information and sends it to a control center. Now, there is a part of the brain that actually regulates temperature. So once it receives this information that, oh no, the body's temperature has now increased by a half a degree Celsius or 1 degree Celsius, then your brain is going to say, nope, we can't do that because, that can disrupt what's going on inside the cell, right? The balance in the cell will actually go wrong. So it's going to send a message to the effector. In this case, the effector would be the sweat glands that's found through the body. So this is a good example to show you negative feedback mechanisms. Another negative feedback mechanism that I do want to explain to you, if you had any bread, candy, anything, fruit, you're going to have a rise in blood sugar, or you may have some rise in glucose levels because that donut, Krispy Kreme, or whatever it may be, will cause a rise. So if you do have a rise in blood sugar, your cells will have to find a way to get that glucose from the bloodstream. So what's going to happen is that through negative feedback mechanisms, the pancreas will release insulin. Insulin is a hormone, and we'll have a video on how insulin and hormones work. So insulin will actually be released into the bloodstream, and insulin will then target to an insulin receptor that will allow glucose to be taken in. Right, so then by your cells. So your cells will take in the glucose, and then your cells can utilize the glucose. Now, if there's any excess glucose through homeostatic mechanisms, the glucose will then get converted to glycogen in the liver and the skeletal muscles, and the blood glucose levels will go to normal. But if they continue to fall too low, so let's say you have an exam and you got up late and you did not eat breakfast and you're just running. So here your glucose levels is starting to dip, okay? In cases of that, negative feedback will kick in again. Your pancreas will release a hormone called glucagon, and glucagon will break down those stores of glycogen that was the leftovers and release it into the blood to try to keep your blood at a normal level. This is an example of a negative feedback loop that occurs in your body every day. Now, we do have individuals that may have disruptions in this process. Those individuals have what's known as diabetes, okay? So glucose levels are an important example of feedback, negative feedback. All right, so quiz time. Hopefully you understand the basics of homeostasis. Let's see. Which definition best describes homeostasis? So select all that applies. So I put biological balance, I put normalizing the body, dysregulation of balance in the body, or none of the above. I'm hoping you picked the right answer. So let's see what the best definition is of homeostasis. Biological balance and normalizing the body. So remember, homeostasis is to ensure that there is balance inside of your body. If you don't have balance, that will lead to disease, and it can even lead to death. Next one, which feedback system is highly favored and most common in the body? We have positive feedback, negative feedback. Both are equally common and favored by the body. I wonder which one is the common one and is highly favored. Which one is going to bring back the biological balance? That is negative feedback. And remember, a lot of students mix up negative and positive feedback because they hear the word negative and they automatically think bad. Negative is not bad. Negative is good because it brings it back. There's a few incidents of positive feedback being great, but a lot of times, not necessarily. So that brings us to this question. Both feedback systems of the body, positive and negative, lead back to the normal set point of the body. Is that true or false? Or do you have no clue at all? Well, the answer is false. Remember, it's the negative feedback that brings back to the set point. That is not positive feedback. All right, so let's go in a little bit further regarding negative feedback. Select all that applies regarding to negative feedback. So the first one is helps to bring the body back to a normal set point, so bring it back to balance, exaggerates the response moving away from the set point, not essential for normal homeostasis, most common and more important for homeostasis. All right, so you're supposed to select all that applies regarding negative feedback. Think about it, all right? Let's see. So we see that negative feedback helps to bring back the body back to normal set point. We know that. And it's the most common and the most important mechanism in the feedback loop. Okay, so if you drink that lemon juice and your blood becomes acidic, or you have too much carbon dioxide building up in your blood, your body has mechanisms of bypassing that, and you should be okay because the negative feedback will help. Now, positive feedback, okay, obviously we know what positive feedback does. It exaggerates the response moving away from the set point, not essential for normal homeostasis. All right, labor is considered what type of feedback mechanism? Is it positive, negative, both, or none? Well, labor is what? Is an event. So if it's an event, then we know that it's positive feedback. Event. So labor is considered what type of feedback? Positive feedback. All right, your body producing insulin to regulate blood glucose is an example of what? Positive or negative feedback. Or is it both, or is it none? All right, so you should actually pick negative feedback. And remember, there's a loop. When your glucose levels rise, insulin is produced, so your cells can take it in. And if your levels dip too far down, then your pancreas will stimulate glucagon that will allow glycogen to be broken down into glucose into your blood. That is bringing to a normal set point. You sweating after running outside in hot weather is an example of what? It's an example of negative feedback. Okay, so your body temperature goes up. The stimulus, the nerves will pick that up, bring it to the actual control center, which is the centers in your brain that regulates temperature, and then sends a message or signal to the effector, which are your sweat glands, to sweat. So you sweating after running is negative feedback. Ovulation is an example of what? What type of feedback? Is it positive, negative, both, or none? Now, remember, ovulation is an event. So if it's an event, then we know that it's positive feedback. Diseases can result in disruption of homeostasis, or homeostasis dysregulation can lead to disease, vice versa. Is that true? Can disruption of homeostasis be an issue? Of course, the answer is true, right? And we see examples like I gave you, diabetes and hypertension. So we don't like dysregulation in homeostasis. All right, using negative feedback, please explain what would happen to a person who was in a car accident and is bleeding internally. Use heart rate as an example. Okay, so one thing you have to think about, let's think critically. If someone's bleeding internally, that means there's a lot of blood loss and their blood volume is dropping. If their blood volume is dropping, that means vital organs like the brain is not getting enough oxygen because there's less blood flowing to that region. And so through negative feedback mechanisms, your body wants to make sure that your brain receives blood. So your heart rate is going to have to do something. All right, so the sensors detect a drop in blood pressure, and the control center of the brain is like, oh no, we need to make sure that we get enough blood. So then it goes to an effector, which is the heart, right? To increase the heart rate, and that's what the answer is. All right, feedback. So if your blood pressure drops, okay, if blood pressure drops, then we actually need your vital organs like your brain to still receive blood because it needs the oxygen. So what your heart rate does is increase to pump the blood quicker to the brain. Now, other things can go wrong with this, right? If the heart's beating faster, it's a potential that you can continue to bleed out quicker and quicker and quicker, and then obviously that would lead to a horrible event. But in the negative feedback world, essentially your body's going to try to increase that. Okay, so using positive feedback, please explain what would happen to a person who got a cut, just a little cut, and is bleeding on the skin. We've all had cuts. What event will take place? Okay. Now, if you said blood clotting as a positive feedback mechanism, you're correct, because you're going to have a magnification of the event, more and more platelets sticking, more clotting factors coming to the site, white blood cells coming to the site to actually clear the infection. So this is an event, healing from a cut. So hopefully you got 100 on this quiz. This is the basic strategies, basic mechanisms of homeostasis. Remember, biological balance, that's the key. We want to make sure every time your blood becomes acidic, it neutralizes. We want to make sure every time your body temperature goes up, that it comes back to its normal range. Blood sugar goes up, it has to come back to normal range. Blood pressure, blood volume. There's a lot of different things that your body would use, a lot of different negative feedback mechanisms that would be used to bring you back. Remember, there is a stimulus that will detect the change, sends it to the control. There's a receptor that will detect the change and bring it back to the set point after the control center regulates what is going on. So if you understand homeostasis, that is great. If you didn't, please go back and look at the video again. Please post a comment. Let me know how well you did on the quiz, if you understood it. And if you didn't, please let me know how I can clarify this information for you. Because every time you talk about a human body system, the body system, every single body system actually feeds back into homeostasis. All right, so please hit the like button. And if you want to continue to get messages or notifications of when I put out more videos, please hit that bell so you can definitely get updates or get notification when we put out a new one. Thank you. Bye. Bye.